Hello, Algebra 2 folks, and welcome to today's lesson. You are going to need your notes, a pen or a pencil, some graph paper, and we are going to begin talking about inverses. So what is an inverse? The definition of inverse is it interchanges the x and y values of a set of points. So if I'm given a table of values, I can take the y's and the x's and interchange them, or make the x's the y's and make the y's the x's. We can also do that in an equation. Okay, so we're going to talk about these two things and show you examples of how that works, and we will get started. So this is the basic idea, and you do not need to write this down. I'm just going to go through this arrow with you and what happens when we do make the arrow of an inverse. All right, so we are given an original set of points to make the arrow, as you can see in this table right here. And to find the inverse, we do exactly what the definition said, exchange the x's and the y's. So for every ordered pair, we exchange the x's and the y's. All right, so we've got -5, 6 here, -8, 6, and then we're going to go ahead and plot these points. So -8, 4, -5, 4, -5, 3, -3, 5, -5, 7, -5, 6, and -8, 6. And now you can see I can draw the arrow. Okay, so maybe it doesn't look exactly like that other arrow, but pretty close. It's a little harder to draw on this than what you will draw on your piece of paper. Okay, so what we have is we have the inverse to the original data. Okay? What we know when we make the inverse is because the roles of x and y are being switched, the inverse is a reflection over the line y equals x. Well, y equals x is a slope of 1 beginning at 0. So if I start my point at 0, 0, I would go up 1 over 1, up 1 over 1, up 1 over 1. This is the y equals x line. Okay? And basically what it says is if I folded my paper on this line, these two would line up exactly. So if you could think about that, if you could think about folding the graph so that the fold was over this line, would those two line up perfectly? Well, they would if my arrow was drawn a little bit better, but it for sure would. Okay, and so that's the basic idea, that an inverse, if you fold over y equals x, they will line up. And you learn that in geometry. So we did talk about that reflection of y equals x in geometry. All right, so now let's go ahead and do some algebra graphs and see their inverses. So this one you do need to write down. We are going to graph the function and its inverse. So we're going to start with a function, okay? And then we are going to find its inverse. So let's go ahead and graph the original. I'm going to put an O for original. This is a cubed function, and it's a function, which means it passes the vertical line test, remember? What is a function? It's where every x has a unique y, right? And this is a cube function, a cubic function, and we know that with a cubic function, we can plug any values in for x. So I'm just going to go -2 to 2. -2 squared is -8, times the negative out in front gives me an 8, plus 4 is 12. -1 squared, or no, -1 cubed, excuse me, is -1 times a negative is 1, plus 4 is 5. 0 is going to be 4. 1 cubed is 1, times the negative is -1, plus 4 is 3. And And 2 cubed is 8 times the negative is negative 8. That would give me negative 4. So I'm going to go ahead and graph this function, negative 2. 12 is kind of off the charts there. Negative 1, 5, 0, 4, 1, 3, and 2, negative 4. I know that my basic shape is going to look something like this. And this is my original. Okay, and if you notice, it does pass the vertical line test, so it is a function. Okay, so now we're going to go ahead and do the inverse. So to find the inverse, what do? We exchange all the x's and y's. So 12, negative 2, 5, negative 1, 4, 0, 3, 1, and negative 4, 2. Look at that, we didn't even have to do anything. We just had to exchange the x's and y's given a table. So 12, negative 2 is going to be somewhere down here. 5, negative 1 is here. That's a better point for 0, 3, 1, and negative 4, 2. And again, we're going to graph that function. Okay, and so this is the inverse. So we call the inverse y to the negative 1. That's our symbol for inverses. Okay, now my question is this inverse also considered a function? We know the first one's a function, but is this one a function? So in order for the inverse to be a function, it also has to pass the vertical line test. And if you put your pencil up there, you would notice that it would pass the vertical line test. So yes, the inverse is a function. Okay? So let's go ahead and do another example. Here we've got the original function is negative 2x squared plus 1. It's an x squared. That's a quadratic function. What does a quadratic function look like? Well, that's a U shape. Okay, and it is a function because it passes the vertical line test. So the original table, when we graph quadratics, remember we're talking about the vertex. And so this vertex is 0, 1. And so then I'm going to use values negative 2, negative 1, 0, 1, and 2, because I found the vertex of being 0, 1. Because it's shifting up 1, but not left or right. That's how I did that. Okay, now I'm going to plug these values in and get my y values. So negative 2 squared is 4 times negative 2 is negative 8 plus 1 is negative 7. Okay, and then I'm going to plug in negative 1. That would be positive 1 times negative 2 would be negative 2 plus 1 is negative 1. 1 squared would be 1 times negative 2 plus 1 would be negative 1. 2 squared is 4, negative 8. That would be negative 7. Okay, I'm going to go ahead and graph this. Oops, negative 2, negative 7. My apologies. Negative 2, negative 7. Negative 1, negative 1, 0, 1, 1, negative 1, and 2, negative 7. And here is our graph. Okay, and it does look like it passes the vertical line test. Okay, and so it is a function. So now let's graph the inverse by switching those roles of x and y. Okay, negative 7, negative 2, negative 1, negative 1, 1, 0, 1, negative 1, 1, and negative 7, 2. All right, there's our graph. Okay, so this is the inverse. This was the original. And if I use the vertical line test, would this inverse function, would the inverse be a function? And no, it would not be a function. It would not pass the vertical line test. So sometimes if you start with a function and you get its inverse, well, they're not functions, okay? So inverses don't necessarily have to be functions. All right, so now that's how you do it with graphing. Now we are going to do this with equations. So we're going to find the inverse function given a function. All right, here we go. So I have y equals 3x plus 5. What we do is we interchange the x and the y, just like we did with the table, but now we're going to do that with the equation, and we solve for the new y. So we subtract 5, and to get y alone, we're going to divide by 3, both sides by 3. So x minus 5 over 3 is the inverse. Now, I wouldn't be able to know if that inverse is a function unless I graphed it or I know something about this. This is a line, and lines are functions, so this would be an inverse function, okay? And we use this symbol. Remember, that's our symbol to tell us that we have found the inverse. Okay, so let's go ahead and do example number 2. Exchange the x's and y's. Solve for y. So in order to get y alone, I'm going to have to multiply by 3, then add 5, and then divide by 4. And we divide everything by 4. So 3x plus 5 over 4 is equal to y to the negative 1. That would be our inverse. Again, this would be a function because it is a line. Okay, so knowing a little bit about the original function will help you determine if the inverse is actually a function or not. Okay, we got example number 3. Y equals 3x cubed plus 5. Go ahead and exchange your x's and y's. Subtract your 5. Trying to get y alone. So we got to get y cubed alone first. So we're going to divide by 3. And now we're going to, in order to get rid of a cube, we have to cube root. And so the cube root of x minus 5 over 3 is equal to y to the negative 1, because this just tells us again, this is the symbol, okay, that says we have an inverse. Okay, so this is the inverse. And our cube, our original cube, is a function. We would have to graph that to know if that was a function or not. Okay, let's go ahead and do y equals 2x squared plus 1. Now, we already know that that was a function to begin with because it's a parabola. And usually parabolas laying on their sides are not functions. So when we get the inverse here, this probably won't be a function. But if you truly want to know that, you would use graphing to determine if it's a function or not. All right, so we're going to interchange the x's and the y's. And then we're going to solve for y. Subtract 1 from both sides. Okay. And divide by 2. So we got x minus 1 divided by 2 is equal to y squared. How do we get rid of a squared? The inverse of that would be square rooting. So we're going to square root. Oh, when we square root, we do plus or minus. So we have plus or minus the square root of x minus 1 over 2 is equal to the inverse. And I know that this would not be an inverse because if it was laying on its side, it would not pass the vertical line test. But again, if you really want to know if it's an inverse is a function, you would use the vertical line test. All right, so we have talked about how to find an inverse a couple of ways. One, you can find the inverse by switching x and y and solving it for that y. That was the last things we just kind of did there with those 4 examples. You can also find an inverse with graphing. You switch the x and y in the table and then plot the new points, and you will have an inverse. And then you have to decide if it's a function. And in order for you to decide if it's a function, we really need a graph in order to do that. And we do that by seeing if it will pass the vertical line test. Another way, remember, x aren't repeating. You know, you can't have more than one x going to two different places, okay? So that is another way. All right, here we go. Thank you for taking good notes, and we will be practicing this up tomorrow. Thanks.